About, actually, before we move forward, I wanted to show this, but do you guys know about Southern India? I know Suresh does. This is more of a nuts Suresh. Now you guys go up here.
He is sending me.
Sending you?
He is sending me.
Just one-way ticket?
I didn't see that was coming.
Anyways.
That's probably why I should go back. Never come back. Okay.
Anyways, you guys, I remember some cases from Southern North America. Well, we're doing this again in India. Showing the slides, just in case you guys are interested, you can go out there and compare you with me, let's have a good time. It's probably, I think, 19 MVPs speaking at this thing from around the world, really jam-packed, awesome sessions. I'm presenting as well backstage, doing some training stuff, which some of you guys might not need because it's really rudimentary stuff, but really, there's a lot of stuff here. Cam Figgy, Cam from England, Cam Jason Wilkinson, you name it, So anyways, it's in August, the first and the second. There's the URL to the website for it. You can register there. It's only $100 right now. Forget about the plane ride, but it's only $100 to get in. Anyways, MVPs get in for free. Doesn't matter if you're speaking. Doesn't matter if you're speaking or not. You just get in for free. But anyways, that's just a distraction. But let's get on to the next one.
They can sponsor the tickets to the MVP. That'd be nice too.
We're also looking for sponsors. Wait, nudge, anyways. Okay, so let's talk about design patterns. So who here knows what a design pattern is?
Book somewhere sitting there.
I saw a book over here talking about.
That's over there.
Head first.
Who wants to take a stab at defining what that is? Anybody? Yeah. All right, let's go. All right, so according to Wikipedia, it's a general reasonable solution to a commonly occurring problem. Okay, that sounds great. What does that mean? Describes how to solve a problem. It can be different across contexts. Okay, so don't confuse. Honestly, the way I would define it is, it's basically it's not really like copy and paste code, blah blah blah. It's really like I'm going to build something in such a way that it will be reusable for different contexts, such as, I have this thing over here, but I want it to work over here, but they have different rules. So I need to have this thing be customizable where I can make it work differently here. That's how I do it. The other thing it offers, and that's confusing, but I'll show you an example of what that is. Provides a language for developers. So basically, you can go into a conference room with a whiteboard. You can say, okay, let's architect a design system or whatever. And you're talking to somebody trying to say, hey, this is how I came up with this idea. So I'm going to have like the decorator over here that's going to decorate something out of Cypher.kernel. I'm going to have the template method pattern over here to have these subclasses that will do things that really are implemented in the base class. And then this guy is going to talk to this guy over here who's using a strategy pattern. So it basically gives you, and the developer who understands design patterns will say, yeah, I kind of get it. You might not know about the weeds, but you understand what, 30,000, thing in the air idea is for this thing. And it's not a cookie cutter solution. You can't copy and paste and say, oh, this is going to magically work over here. It doesn't work like that. All right, so where did this come from? So this is interesting. This does not come from software engineering. It comes from building in city architecture by this guy who was a professor at Harvard. This guy was just an architect, not a solutions architect, not a software architect, a buildings architect in the city plan. He basically came up with this idea and he wrote a book with it, a pattern language, towns, buildings, and construction. So he's like, he toured Europe, he toured America, he's looking around, he's like, I see patterns here. A good city has this feng shui going on, and he uses that word. But let's say, you build this like this, and then things flow like this, and things like that. We're a whole book on it. Anyways, some really smart guys, you know, that are in the software engineering field that you might recognize. Ken Beck, who's out there, he came up with a book on TDD, does all kinds of other good stuff. And then Ward Cunningham was one of the, I think he was one of the Gang of Four guys, maybe not, but he was an agile guy, really big on development, still out there doing things. They basically read this book and they're like, whoa, we can apply this to software engineering, science, applying software. It's like, oh wow, who would have thought that we could take some other field and make this work? And then they presented this at this Oops Law conference way back in 1987. But, all right. I mean, as developers, we've seen solutions get weird things like this. You'll have, you know, this guy that, you know, is built like that, but then it interfaces with this over here, and then it looks like that. By the way, you know, my birthday's over, but, you know, I'm looking for belated birthday gifts. You know, you have my address. You send me one, anyways. Then you get weird things like this, you know. You all recognize what I'm talking about. You just get weird solutions. All right, so we're going to talk about specific design patterns here. I'm not going to talk about all of. There were 23 from the Gang of Four book, which is a really good read. Actually, it's a very boring read unless you read another book that tells you what design patterns. Then you can understand that other book. But I thought it was a good read after reading other books. Anyways, I digress here. Decorated pattern. So, what is this guy? He's a, you know, basically a wrapper. So let's say he's a class that implements, let's say, an interface that takes in an inner object that has the same interface, and he'll override the same methods, and then call the inner guy and change things inside. So you can add, remove, or alter functionality of how the inner guy works with his methods. You guys like UML? So this is basically, you know, how you think about it. And I actually don't like the way this is built because I think this is rubbish. You don't have to deal with this. But anyways, you have a component, and you have a concrete component, and you have a decorator, and a concrete decorator. Really, so this guy implements this interface, then this guy implements this interface, and that guy implements that interface. Well, you don't need that. You don't need this guy. You just need this, and then this guy implements that, and that guy implements that, and then grabs this guy. I don't know the UML for it because I didn't finish the book. But anyways, you're wrapping a class with the same interface and you're changing things by delegating. You delegate to the inner instances method, and then you change data that's returned, or if it takes in an argument or parameter, you can change what you're sending that's coming from a caller. So let's see some code. All right, so I'm going to look at some code. I'm going to write it now. So if we go here, so you guys know about the ID table in Sitecore? You put stuff in there, you know, some kind of like mapping from an item to something else. So we have this. Woo! Anyways, zoom in. All right, is that good? Good. Good, yeah, okay. All right, so we have a pipeline processor, a to request processor. It's another item resolver. So what are we doing here? I'm injecting an instance using the Sitecore configuration factory of something that's I'm injecting into with a nested XML element. What I'm injecting here really is the item resolver, which I'll show you in your video in a second. Assuming I still have it. Anyways, I just want to search the properties, make sure we have the inner guy set. That basically means the developer messed up. We did some configuration on it. And prefix is something that I need to use to look up key value here inside the ID table. So you can store multiple things in the ID table, give it a prefix, and make it more unique. So you can use the ID table in really different ways. I've seen people use it for like magical URL, not rewrites, but more like mappings, like hey, if you have this URL, a command URL, go over to this page over here of this item. So you can use the ID table for that, which I did in this example. I get the item based off of this path. Basically, we're not doing anything crazy, we're just, you know, I'm getting the ID based off of this URL, which is key into the ID table in my database. if I get that and I get the ID from it, and if it's set, then I return the item that represents the ID, just using the item in the DB instance for current contact situation. So that, but it's here somewhere. So we return, oh, right here. We're just doing this, context database. I mean, probably not the best code. You should have content database, which you want to ask or this, no why. Anyways. So we get that, we get the ID item. If he's no, we delegate to the inner processor. And then we get it. Otherwise, we send the context. Alright, so we look at the config real quickly. Should have had both. And decorated. Let's see. Is this the right one? Zoom in. We have an HTTP request begin pipeline processor. I'm patching it instead of the item resolver. In the last presentation I did before, this time I'm wrapping it. Not like vanilla ice, but I'm wrapping it. And then passing the prefix. So this is going to have the unique key value here inside the ID table. And then here's the inner processor, and that's it. So this guy will run on every request made to Sitecore, whether it's shell, website, whatever. You might want to start reading not to run shell, but well, I didn't do that here. And so we look at how this works, and like I said, I can't show you this live in Sitecore because I destroyed that instance. But I have slides of it, which really helps a lot to see what's going on. Here. So I don't know if you guys can see this, but we have a Super Mario cat on this item here. And this is where he lives. There's that cat here. And he says meow. Here's an entry into my ID table. Basically, I want to say, okay, if I get a URL like this, I want it to load this item that's here, which is located. So if we actually load it, we get the page because it's resolved magically by the ID table that grabs the item from the database. And then boom, right here. By the way, that's marquee, it goes back and forth. Unfortunately, we don't have any intermediate gift for that. So that's an example of a decorating pattern. Now, is it always good to do stuff like this? Well, think about decorating a decorator that decorates a decorator. How do you maintain something like that? How do you troubleshoot it? You have to go find this thing. Maybe you have to configure all it's magical. Well, yeah, I can find it here. But let's say you're not doing it. Let's say you're decorating it by just doing other things. I don't know. You have a DI framework that's actually not because everybody has to be introduced. But let's say you're doing it differently. You're decorating this thing in multiple million ways. You don't know where to find the bug. You have to go through all those things, and you have this crazy uneven layer, structure to go find problems. And they could live in different DLLs. You might not have the code basically. So what are you going to do? Decompile it? Let's just say it's a nightmare if you have way too many nested decorators. So that's the point of what I'm trying to make here is, yeah, design patterns sound cool and all, but they're not always that. Here's an example of why not. I mean, look right here. This is a cool example, but let's say you have the nested examples that I said. Kind of scary. Which brings me to the next one. Well, actually, look, this resolves back to the original condition. With the original URL. Nothing magical. This basically just, we'll just use a regular out-of-the-box auto resolve this way. Template method pattern. So I like this design pattern. I'm not going to say I like it a lot. I'm going to say I like using it because I see a lot of power with it. But it has its problems, which we'll get to. All right, so let's talk about what it is. Oh my God, we're using the word algorithm again. All right, so you're defining a main algorithm inside of a base class, something. It's an abstract base class. Basically, it has methods that might or might not be virtual that have stuff in it, and then you define abstract methods. So the virtual method would be called the hook because you're going to into it and change it. The abstract method is called stuff. And I forget where those terms came from. It might have been game before, but I read it somewhere in this article. Anyways, when you have both, The abstract methods let you change the way the main algorithm runs in the method that's calling those other methods that need to be defined by the subclasses or changed. So you get virtual hooks. So you change the default, or you have abstract. That means you have to define, and then some magic within the base classes running on stuff. So another UML type of diagram. A is abstract. I think F is final. This is like from C++. But anyways, it's the best image I could find. And then you have something called this, which I believe is a virtual method, but I don't remember fully. So I think it is because it's being defined down here. So we have our abstract class. We have abstract methods that need to be defined by the subclass, which is this guy. These final guys probably are using a combination of this and this one here. And then this guy's virtual, and he can be overridden by a concrete subclass. So this is basically it in a nutshell. And then, this is basically defining an interface where it has something. But really, this is for a caller to say, I want to use an instance of this guy, which could be this guy. And then there could be different types of these guys, which, different types of these guys that do this differently. That's the type of method. So some code. So I'm going to go to the config file first because go to the config file first because there's a lot of stuff here. Right? I wrote blogs on this, by the way, and I've done presentations on this particular stuff. So there was, I did 2 sessions for Sitecore Experience, which was the video podcast, which I talked about a bunch of different design patterns and how to implement some of this in Sitecore. They're out there, go have a look, help me understand some of this better because I'm going through it quickly. All right, so you guys know about content editor warnings in Sitecore. So it's that yellow box on the item when you're in the content editor that yells at you for some reason. That's what a content editor warning means. So here, what I did was define a family of, I would say, warning guys that would show up for different reasons. So let's say we had an item with invalid characters in their name. I'm making this totally up. Let's say that somebody puts a $sign in the item name, which I don't even know if you can do it, or a hyphen or whatever. Totally arbitrary, nothing special here. We want to say to the content author editor, hey, you can't do this. Give a big yellow box yelling at them, give them a way to fix it. And then I created another type warning that says, hey, actually I think this is it here. Oh, you have too many sub-items. You have more than 20. I want you to convert this into an editor. So this config is just defining something like that. I have 2 pipeline processors that do this with this pipeline here. So I don't know if you guys can notice where this is going. We have a command here. This is a shared UI command to say how to resolve the problem. So we're just going to put that in the link. They can click that link button. Magically, Sitecore takes care of the rest and lets them fix it. And then here's the link text for an item bucket, or we name the item it's from, the characters in the name. That's all fine and dandy. Let me give messages and stuff. Content editor warning. I think I have screenshots of this. I should show you in person, but I can't because that section's gone. But anyways, if we go and look at this guy, so pattern. Here we go. So we have, I'm going to just go down here very quickly. That one ahead. So we have this guy here. This is the abstract class, basically. He's basically the main algorithm guy. Sounds exciting. So he has a process method. He's basically calling it warnings. You get a collection of these warning guys. Which this basically is just nothing special. You have title, message, links to resolve the problem. Does it have any content? Basically, we're just checking to see if these are empty. And then the ability to clone, which I didn't use in the solution, I used on a different design matter solution, but I haven't defined it here because I'm lazy and want to define another interface. Plus, why build another interface if it's the same thing? Anyways, so we go back, get in those collection of warnings. If we have any, we don't have any. Get out. Otherwise, we display them to the user using this add warning. So, do they have this, does this thing have content? We're going over all of the reiterate. Does it have anything? No, otherwise we're going to add it to the collection of things that need to be displayed to the user. And this stuff right here is basic Sitecore API stuff. This is how you would add a warning to content. It's here in the yellow box. I'm doing translating here using the dictionary because I like to offer multilingual solutions. Too, because some people might be speaking Japanese, we don't know, but we want it to work very quick. Go back, and then we just keep doing. We're just adding this the yellow boxes. Nothing crazy. This guy's abstract. This means that subclass needs to define it. So, and then this is the main element here to make it all work. I made this a hook. In case they need to change how that works, they want to know because this uses that group API stuff. So we go look at the subclasses. We talked about, the processor that says, hey, you have too many sub items. I'm going to yell at you. He doesn't have to, define the processor. All he has to do is define the warnings for that because it's action. He's basically we have a collection of unique characters found. So what we're doing is we're putting the hashtag. I don't know if you guys know what a hashtag is, but you can put things in it and it will ensure the unique. So if you put the letter A like 50 times, you only have one A. It's just a set of stuff. So basically we are adding to it invalid characters that we have found, which is being set here, which is being injected from the Sitecore configuration factory. Config file, which I obviously don't have open anymore. So basically it's just a list of this stuff right here. By the way, you can inject a list of stuff into the classes from Sitecore using the configuration factory by doing int list. It'll magically just get populated to a copy as a list. Well, magically, it's an item. And you need to instantiate your list in order to work with this. Anyways. Tangents, because that's what we do. Go back here. Nope, not it. So that's the problem with having two solutions using two design patterns to do the same thing, which you're going to see that code next. Alright, so here's the instance of grading for this. So those invalid characters, we have them here, we're reading over them. Does a name contain it? If it does, we add that character to this list. And if none are found, we just return it to collection so that it exits and does nothing. Otherwise, we get a clone. I lied, I did use a clone method. And then I'm basically joining these together so that we can display them in the content editor running here at the yellow box saying, oh, we found all this stuff and we need to fix it. And then I'm just doing magical stuff. We just make them pretty so we have weird commas at the end. So you can totally just ignore this because it's not relevant to what I'm talking about. And then I'm doing some replacement to make the message pretty. I'm asserting the properties I need to make this work. This will throw it, yellow screen adapter to your stuff as set up config. The splice method is, it's just doing a splice. I'm not even going to go into what that means. It's not important. It's just to make the string work. And then I have to open some kind of just kind of replacement on it. So that's that guy. If we go back to the next guy. So this guy's looking at too many challenges. So he also implements, I would say, inherits from the same base class. He has to implement this guy. We're saying, okay, if he has 20 or more, depending, based on what's in the config file. Oh, sorry, I'm right here, this guy right here. So if we go back, so if we have that many or more, sub-items, or child items, I should say. If we don't have that many, we get out. Otherwise, we get a warning, which is injected from the configuration factory. From the config file, so I know I'm talking about before, which is this guy right here. We're injecting that in, and returning it back to the caller, which actually is the base classes process method, and then that returns to the secondary API saying, hey, we got the user for this. So if we go back here real quickly, I'm also doing this over here. I decided to make this private because I didn't see any utility in making it something that should be in the base class, and maybe I was wrong, I don't know. I'm weird. Anyways, so if we look at how this worked, well, this is not what I want to show, you should see that. That's a secret. I think we're going to see it. Anyways. Alright, so here we go. I don't know if you guys can see this. It's very blurry, but we have two content editor warnings that show up. Because this guy right here has invalid characters in his name. We have a hyphen or one, which is and then we also have to meet some items. I think there were 25 here. So they both show up. So if you click on the ability to rename it, you change the name. After you change the name, this is valid. The other, one warning goes away, the other one's still there because we have too many sub-items. Convert it to an item bucket. Yes, sure. It does its magic. And boom, no more problems. The content editor warnings are gone because we've resolved the problem. Alright, so before we move on to the next one. So I like using this. I like the template method pattern where I can define something with a base abstract class. However, you're tightly coupling your code. So if you make a change in the base class, you might break stuff on the subclasses. That's the caveat here. You are basically, marrying your subclasses to your base class. And that might be good, depending on what you're doing, it might be bad. Let's say you have like 100 subclasses in this thing, and they're all doing different things, and you make one little change in your base class. You're gonna break everything. You have to go and fix it. What fun is that? Well, then you might give it to somebody else. But anyways, the point is, you're gonna lose money because you're fixing the bug with something that was designed for you. So that brings us to the next one, strategy pattern. Now this one's always confusing. I always get confused by this definition, but I think this comes from the game before. I don't like it, but that's what it is. That's what they're saying. It defines a family of classes with the same interface. They actually use a different term. I actually wrote this myself to explain what it means. Where, so they talk about, it defines a family of classes that does blah, 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 and it has blah, 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 again. Basically, in a nutshell, it defines the same interface. We encapsulate an instance of each one of these guys, and then we make them interchangeably within that family. But yeah, no kidding, because they have the same interface, right? And we can reuse them because they have the same methods to find them. So here's what we're going through. So we have a context item, so this is not like a context, this is something different. We have a strategy object. He has this method defined. And then we have concrete guys. This is an interface. This guy defines these guys here, but really, this guy is being used in a particular context, which is kind of which is also used somewhere else. So there could be a context object that will iterate over a collection of these other guys, and they don't even have to iterate, whatever. And then it needs to be applied to that context. I know it's kind of confusing. The code's even more confusing. See some code. So in this case, I defined really a solution to solve the same problem. This. So that's the other thing about the strategy pattern. It replaces the template method pattern with a subclass, so you don't even inherit it. So, what I showed in the UML diagram is kind of like crap, because you don't need to have an interface necessarily for this card for you guys. What you do, it's a family of algorithms that you're defining, and then the context guy bridges that together. It's not bridge guy, bridges it together to use it over a different class. It's basically non-inheritance on steroids, to be honest. So we go look at this guy, and this code is, I always get lost in this code, and that's the problem with this code, in this iPad. It's lost. So I remember I stumbled over this and stuck on here. Anyways, let's see if I stumble here. So we have, I guess we'll jump into this guy really quickly. So they're going backwards instead of going forwards, so I don't know why that happened. All right, so I have one, actually let's look at the kickoff first so it makes sense. Strategy. So we have almost the same stuff, same messaging, same number of sub-items that are too many, same invalid characters, right? Same stuff that will show up in the yellow box, except we're using that warning class again. Everything's the same, nothing's different. Except the difference is we're using one pipeline processor here now. That's this guy, which I'm about to show. What he's doing is configuration, or cycle configuration factory, I should say, is injecting an instance of these generator guys into that pipeline processor, into a collection of those guys, into a list. And so we have the generators, and the generators will generate the warnings. Really, it's doing magic, by looking at things, ranking items, ranking valid characters, blah, 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 and then we pass back instances of these warnings. So if we go back, this is it. Let's look at this one. I know I wanted to show the pipeline processor, but I'm not going to yet, because I think it makes sense to show this first. So we've already seen this guy using the same exact one interface. There's a class that actually implements this. I can show you what that looks like. It doesn't really have much to it. Basically, it has properties, public properties to do this, to define these guys, and that guy. And then we have a has content that makes sure that these two guys here are now whether I do white space or whatever. And then that just returns an instance with all this property on it. So I don't think that's important, showing that. But we have these warning generators that basically generate warnings. So we're doing the same thing. I'm looking at hash that here for invalid characters, iterate over them, add them to the collection here. If we don't have any, we return nothing. Otherwise, we build up a string display property in a link to resolve it, saying, okay, this is how you fix it. Here's the yellow box. Okay, fix it that, whatever. If we go to the next class, he's the generator for 2 sub-items. This is here. I like how the sentence goes. Let's talk about kind of the same thing. We have 20 or less sub-item job items. We just return them to collection. Otherwise, we return an instance of the one that was injected in. That was set on the AMI cycle configuration. This is being injected also by cycle configuration factory. I see that over time and lock. I think my jaw will lock, but anyways, and I'm doing the service on this. Anyways, if we go back, this is where it gets really confusing. Let's see. But yeah, let's see. Anyways, everybody has an interface. Generators have an interface. This is why they're interchangeable within the same family. They have the same interface. And they're going to be used within a context, which is going to be this guy right here. We have a class that implements this interface. We get the warnings from those warning generators, and then we have our warning generator. So this guy is going to magically get instantiated. We get the warnings from this guy based off of this item. this method. So I know it's kind of weird. So let's go and look at what that looks like. Find this guy. So we pass in, this generator is getting set magically in code. You know, the calling code has to set this on this property using the mutator or set. And then we use the accessor or the getter down here. And then you have the item, you set that on this guy, we call generate, returns the warnings that generate. Now this is where, like I said, this is kind of weird looking, right? If we go back here, we have our process method, that's the pipeline processor starting point. We get our warnings. With no warnings, we get out, otherwise we iterate over them and we add them. So that's just the main algorithm here. If I jump into this guy, alright, what's this guy doing? Iterating over all generators that were injected in using cycle configuration factor. We get the warnings by passing the generator in the item. We set the generator on it using the mutator of that property, and then we call to get warnings for the item for that generator. Pass it back. If there aren't any, we get out, otherwise we just keep going. So that's going to hit that iterator. So for both generators, hit the warning has it. Alright, you're probably thinking, what is going on? Well, this basically gets rid of inheritance. The context seems a little weird. I thought it was a little weird too, but I think it's still a little weird to be honest. But it's just really using delegation a lot here. That's what it's doing behind the scenes. Unfortunately, it adds a lot of code complexity. So that's one of the problems with this thing. It adds a lot of code complexity. There's a lot of moving parts. There's a lot of places where this might be hard to maintain. But if you make a change in code, you're not going to break anything else. Like you move the type of pattern. That's the benefit. You're abstract. You're basically just using composition instead of inheritance. But there's a lot of stuff to maintain, and a lot of parts, and whatever, all the stuff we call. I don't know if I need to show how this works, because it works as the same thing as the last one. I don't know if I actually put these slides in again. But anyways, thank you for coming to Cincinnati Sitecore User Group 2016.